Welcome to the engineering technology class for March the 3rd. I am recording this for the benefit of the many people who aren't here. I'm really surprised there's so many people missing. I'm guessing that there's some sort of event going on that I'm just not aware of. So I'll record this for everybody's sake because what we're going to do today is really important. And well, okay, so let's just go ahead and jump into it. First off, I have looked, okay, here comes one of the people who's missing. Let me let her in. Hang on a sec. Okay. All right. So I have looked at the functional specifications that you guys submitted. I haven't graded them yet because I'm going to grade them a little differently than I did last time. Last time around, what I did was if you had most of the things, if you mentioned most of the things, then I just gave you full credit. But what I discovered the hard way is that when I gave you full credit, many of you assumed that that meant that your functional specification was complete. And so when you actually did the penny launcher, you left out some of the things in your final penny launcher because you hadn't mentioned them in your functional spec and I hadn't complained about it. And so that's kind of on me. It's my fault for not complaining about it. So I'm going to do it differently this time. What I'm going to do is I'm going to make up a list of everything that I think should have been in your functional spec. I'm going to post it on Canvas and I'm going to post it in the form of a rubric. And then I'm going to use that rubric when I assign a score to your functional specification. And so if you're missing something, anything, you will then know. Okay, you got somebody else coming in. Hang on a sec. I'll let her in. Okay. All right, so that way, if you leave something important out of your functional specification, you will get some feedback saying, hey, you left this out, you left that out. So that when you then do your final project, you can't come back to me and say, well, hey, what I did matched my functional specification and you didn't complain about the functional specification, so why are you complaining now? Okay, so I don't want anybody doing that. All right, so that's why I haven't yet assigned scores to your functional specifications. But for the most part, most of you got it pretty good. I just got a message from one student saying that somebody's Canvas is not working. I'm having trouble with Canvas too. In fact, just in the last 10 minutes, I've noticed that Canvas is not responding well. So maybe they're having a problem with their servers there. So, okay, yeah, somebody else just confirmed that they're having trouble with Canvas as well. Okay, so apparently they're having trouble on Canvas's end, but that's okay. I trust that they'll get that figured out. Okay, so as I started to say, most of you did a pretty good job of summarizing everything that was required, but some of you did leave out a few important things. And so the plan for today is we're going to do some brainstorming. But before we do the brainstorming, I want to make sure that everybody understands the things that some of you left out. Okay, so some of you, the way you wrote it, it sounded like you were like I was requiring you to take the template that I gave you and use the template as is, the same size, same fins, same everything. The way you worded it, it wasn't quite clear, but it sounded as though you were thinking that you weren't allowed to vary anything in the template, when in fact you are. In fact, you don't even have to use the template at all if you don't want to. You don't have to have fins if you don't want. And if you do want fins, you don't have to have this side fins. You can have bigger fins if you want. You can even add stuff on there. Like what I've got here is a paper airplane. There's zillions of different ways you can make paper airplanes. This way is one of my favorite designs. What I've done is I've taped the paper airplane onto the rocket part so that we're going to launch the paper airplane. Now it has to be launched from the launcher. Okay, that is a firm requirement. Okay, but what you launch from the launcher is totally up to you. if you want to go with the template as is, that's fine, but I would recommend you make some modifications to it. So hang on a sec, somebody else just got here. Okay. And so what we're going to talk about today is what are the types of modifications that you might want to make. We're gonna brainstorm all of that today. But again, okay, now there is one thing that you are not allowed to vary, and that's the launcher. Now it doesn't have to be made out of colored paper. I just did that because it's a little bit easier for me to keep things straight. So I don't care what color the launcher is, but the launcher has to be a sheet of 8.5 by 11 regular weight paper. It can't be tissue paper, it can't be cardstock, just, you know, the regular printer paper. And the diameter has to be the size of a penny, right? So you have to be able to take a penny, and I had a penny sitting here. Where'd it go? Here we go. Okay. So you have to be able to take a penny and you have to be able to put it inside there and have it just barely fit and turn it around various ways. Okay, so it should be big enough that the penny can go inside, but just barely, right? And it has to be 11 inches long. That you are not allowed to vary. But what you put on the launcher, hey, you have a wide range of things you can go with that. Okay, when you launch it, it's very important that everybody has to launch it from a initial height of 4 feet. Now, you know, if it's 3 feet and 11 inches, you know, I'm not going to worry, you know, plus or minus an inch or two. Now, as far as the angle goes, you can launch it at any angle you want. I recommend that you launch it at 45 degrees. But, you know, if for some reason you want to launch it at a different angle, that's up to you. Okay, so the allowed materials for the flyer, that's important. So whatever your flyer is, needs to be made out of paper. Does not have to be one sheet. If you want to take 2 sheets and make some wings and add it, that's okay. If you want to take 2 sheets and stick them together so that instead of having just a normal 11-inch rocket, you know, you got a rocket that's maybe 20 inches long, hey, that's fine. As long as it's made out of paper and as long as it's held together with tape. Now, if you want to add weight somewhere in your rocket, and the logical place where you might want to do would be in the nose cone, but you don't have to if you don't want to. But if you want to add weight, you can add pennies, and you can add as many pennies as you want or as few as you want. And you don't have to put them in the nose cone. I mean, if you want to put them in the tail, hey, you put them wherever you want. So paper, tape, and pennies. Those are the only allowable materials. And okay, the other thing that I mentioned last time, and some of you put it into your functional specifications, was that I wanted it to be, the next milestone was going to be this coming Saturday. I've since thought some more about that, and I've changed my mind on that. I want to do things in a different order. What we're going to do today is we're going to brainstorm. And then after we do the brainstorming, I'm going to have you write up a kind of a summary report of the brainstorm and what you think. Well, I'll explain that in more details in just a minute or two. But I want that to be the next deliverable. I want that to be the next milestone. And I'm going to give you a fair amount of time to do that. So you are not required to actually make a prototype or test a prototype until later. It'll be sometime next week. The only thing that's going to be due today, or the only thing is we do next time we meet, will be to write up something that summarizes the brainstorming session, which we are going to have in about 1 minute from now, unless somebody has any questions. Does anybody have any question about the functional specification? Is everybody confident that you fully understand what is the job that you need to do? So tell you what, type into the chat box in a private message. Tell me yes if you are confident that you fully understand what the customer wants. And if you don't fully understand, then type in a question. All right, so I'm seeing a couple of yeses. Seeing a lot of yeses. Not seeing any no's. Okay. All right. So remember, as with pretty much every project that we do, the real, true, deep reason why we're doing this is not because I want you to make a flyer that that flies through the air. The real reason we're doing this is to make sure that you understand the engineering design process. And so we need to follow the engineering design process. So step one is meet with the customer and write up a functional specification describing what the customer wants. So we are now done with step one. We're ready to go to step two. Step two is brainstorming. Right. So the first thing that I want to do is I want to list all of the variables that might possibly affect how far a flyer would fly. So hang on a sec. I'm going to open up a document here. I'm going to do it in Google Docs so it's a little easier to share. Okay. And so come on, I want to go to Google Docs. All right. Okay, so I'm going to create a new Google Doc and then I'm going to share this with you guys. So I'll just share my screen right now. And then once we create the Google Doc, I'll actually share the document with you on Canvas. Okay, so what I want to do is I want to list all of the variables that might possibly affect the flight distance. All right. So what do you guys think? What are some variables that we might want to play with? Okay, so I see Jacob is suggesting that the number of pennies. And I assume that you're talking about in the nose cone. So let's say that number of pennies in the nose. Okay, so that is a variable. So yes, it's and let's talk through that just a bit. So you guys have not yet had physics. So, but you have in junior high school, I'm sure you've seen the equation F equals ma. So F stands for the force, M stands for the mass, A stands for the acceleration. That's Newton's second law. If your junior high school science teacher did her job correctly, then you will have seen that equation. What it means is when we're trying to accelerate this rocket, the more mass it has, the less acceleration it's going to have. Okay, so that makes you think that putting a penny in the rocket is actually going to be bad, not good, because the heavier the rocket is, when we go blowing on the rocket, the slower it's going to be when it leaves our launching tube, and therefore the less far it's going to go. So you might think that adding pennies into the nose is a bad thing, but F equals ma also works during the time that the rocket is flying through the air. So as the rocket is flying through the air, it's going at a certain speed, and the air resistance is trying to slow it down. The more mass it has, the less it's going to slow down. Okay, so once it gets going, the mass in the nose is going to help it keep going and help it fight against the air resistance. So in that case, having more weight in the nose is going to be a good thing, not a bad thing. So it's very likely that having a little bit of weight in the nose is going to help, but having too much weight in the nose, that will hurt. Okay, so the amount of weight that we put in the nose is very definitely a variable that we want to think long and hard about. Okay, so the next one that I see is size. And so Nate, when you say size, what do you mean? Size of what? Can you unmute yourself and tell us?
Size of the rocket or airplane.
You mean the length?
I guess all of it, because like if it's too big, then it won't fly very well.
Okay, so let's put them out separately then. Okay, so we've got the length of the rocket. And but you are correct in saying, well, there are other things we need to worry about too besides just the length. Okay, so like the size of the fins, okay, which is what I see. Okay, so Tatum is suggesting size of fins, and actually so are a bunch of other people here. Okay, so let's put that size of the fins. That's a variable. And I see that we've also got other people. Hang on, somebody just joined us here. Let me let him in. All right. And so Lily is suggesting also the size of the wings if we decide to use wings. Okay. All right. So that definitely is a variable we need to think about. Okay. And then Jacob is saying that if we use the fins, the size and the angle of the fins. Okay. So tell you what, let's have this guy up here. Let's just be, the variable here is the fins. And then what we'll do is we'll say size and shape of the fins. And let's do the same thing for wings. So size and shape of the wings, if we decide to go with that. Okay. All right, let's see what other variables the people got here. The nose, okay. All right, so the nose is important. Okay. Do we want it to be pointy or blunt? Okay. Let's see what else. Okay, so I see the angle of the launch here from Jacob. You know what I think I'd like to do is I'd like to not have that be a variable. I want to focus on the design of the flyer itself. So tell you what, I'm gonna change things a little bit. I know I told you previously you can launch from any angle you want, but I've changed my mind on that. I'm going to say that everybody is required to launch it from a height of 4 feet, and everybody's required to launch it from an angle of 45, because I want the variables that we play with to be variables that are related only to the design of the flyer, nothing else. Okay. All right, let's see what else people got here. I'm looking through the comments here and I'm not seeing anything that I haven't yet captured. If you guys want to unmute yourself and speak into the microphone, that's okay too. I got fins, I got wings, I got the nose, I got the weight. Okay, the width of the rocket. Okay, so let's go up here. Let's list that as a separate one. So the length of the rocket and the width of the rocket. Okay. One thing that nobody has said anything about that I think is important. When we roll the rocket, in fact, let me stop sharing for just a second here. Okay. When we roll the rocket on our launch tube, one variable that we didn't talk about is how tightly do we want to roll it? Do we want to roll that thing on there so it's super tight, or do you want it to be maybe a little bit loose? That's a variable that could have a big factor in on play. So let me go back into here. Let me share that. So how tightly we roll the rocket. Okay, that's an important variable that we should think about. Yeah, Tatum, that's fine. Don't worry about it. Okay, so a couple of you have just mentioned blowing strength or how hard you blow. Okay, now that again is not a function of the rocket or the airplane. Let me call it the flyer. Okay, rather than calling it a rocket, let's just call it a flyer because depending on how you design it, it might look more like an airplane than a rocket. Okay, so how hard you blow it, again, that's not really a variable of the rocket. That's a variable of the launcher. And that's something that I want to keep exactly the same. So I want everybody to launch from the same height at the same angle. And I want you to try to blow with the same amount of force every time you blow. Now I realize that it's impossible to always blow exactly the same strength every time. If we were in my classroom, I have a pressurized air tank that we would use where we can be sure that the pressure is the same for every launch. And that's what we would do if we were in my classroom. But you know, we're not in my classroom. So hey, what you gonna do? All right. Any other variables that you guys want to think about here? Right? Not hearing any, not seeing any. And can I think of any that we haven't captured? I'm thinking we probably got them all. Okay, so let's see how many variables have we got here. So I'm seeing 1, 2, 3, 4, 5, 6. So we got 7 different variables that we want to play with. Okay, now, so in your homework tonight, what you're going to do is you're going to write this up and you're going to write it in a table format that we call a matrix. And in fact, while we're at it, let's go back into Google Docs here, and let's see about how do we do tables here in Google Docs. So, okay, so what I want to do is I want to insert a table. So I'm going to come in here. I'm going to insert table. I got a bunch of stuff in the way here. Let's try it again. I'm going to insert a table, and I want my table to have 7 rows because we got 7 variables. Actually, tell you what, I'm going to have to be 8 rows because I want the first row to list what the things are, and I want it to be 4 columns wide. And you're going to find out in a minute why I said that. Okay, so I'm going to add in a new table, and so along the top here, we're going to list what each column represents. So the first column here is going to represent the variable. Okay, and what happened to how that one? That's supposed to be how tight. Okay. All right, so the first column is the variable. Now, these next 3 columns, they represent different settings for the variable. And you're going to know in a minute what I mean by that. But let me just, right now, let me just call it a low, a medium, and a high. And we probably want to, I mean, if we want to be fancy, oh, that's what happened to the rest of it. That's weird. Oh, I think I know what happened. Okay, so I would like all of these to be centered. Not that it matters a whole lot, but, and then let's get rid of all this down here. We don't need it anymore. Okay. All right, so our first variable is the number of pennies that we put in the nose. Okay, so let's make a note here. So number of pennies. Okay, that's the first variable. So I see Jared's asking in the question marks, can you use Google Sheets? Yeah, everybody can use Google Sheets. You need, oh, are you saying you want to edit it? Tell you what, let's hold off on editing. So let me do the editing for now. And then later what I'll do is I'll let you come in. Okay, so now what I want to do is, so I've decided that one of the variables that I might potentially want to play with is the number of pennies in the nose. And so now I need to pick 3 settings for what I might reasonably want to use. And so the lowest setting, I think that one's pretty clear. That would be 0, right? So one of my prototypes I would like to make that has no pennies in the nose at all. And then what I need to do is I need to come over here and I need to pick. So if I were to use pennies, what's the maximum number of pennies that I would realistically expect to do? I mean, you could come in here and you say like 100 pennies, but that's not realistic. I mean, nobody's ever going to go with 100 pennies in the nose. That would be so heavy the thing wouldn't fly at all. So I need the highest value here to be something that's realistically something that I would seriously consider doing. So I'm thinking maybe 4. I guess now some of you might want to go with more, but I'm thinking 4 is a realistic high value. And then I'd also like to have an intermediate value there. And so the intermediate in this case would be halfway between 0 and 4, which is, that one's pretty obvious. So 2. Okay. All right. So you see what we're doing here is for each one of these variables, we are going to decide what is the range with which we want to play with these possible variables. All right, so next variable on our list is length. So let's go in here. All right, so now I want you guys to speak up. What do you think? And I guess it would help if I spelled length properly, wouldn't it? Okay, what do you think is the shortest realistic rocket size that any of you would ever consider going with? All right, so I'm seeing some people are saying 3 inches, some people are saying 1/4 of a sheet, one person's saying 6 inches. Okay, so 5 inches, 4 inches. Okay, so we're all kind of sort of in the ballpark there. If I were to take the median of what you guys are all going with, I'm going to go with, say, 5. Now, that doesn't mean that you guys have to go with 5, but I'm thinking 5 is a realistic inch thing. So I'm going to say 5 inches. Now, how about the longest that you might realistically go with? Okay. What do you think is the longest that anybody in their right mind would want to go with? Okay, so I see somebody is saying the full sheet of paper. But, you know, when I've done this in previous years with other students, I've had students where they take 2 sheets of paper and they put these 2 sheets of paper together to make a super long rocket. I've seen several people do that. Okay, so if we went with 2 sheets, that would be, you know, each sheet is 11 inches long, so that's 22 inches long, but we want to have a little bit of overlap because otherwise they're not going to work together. So how about if we say 20 inches? Okay, so yeah, Alexander, I agree with that. So 20 inches, that's the maximum length that we might realistically want to go with. Okay, so what we need is some intermediate value there that's, say, halfway in between. Now, I'm going to go with the 11 inches as my halfway, not because 11 is actually halfway between 5 and 20. It's not. But 11 is a good value because if I were to just go with 1 sheet of paper, if I were to just go with the template as is, that would be 11 inches. And so that makes that be a nice convenient value for my medium. Okay, so my shortest rocket would be about 5 inches. Medium would be the template, which is 11. And if I wanted to, I could take 2 of them, tape them together. And I think 20 inches is the longest that I would realistically go with in a case like that. Okay, so let's continue on down here. The width of the rocket. Now, I don't fully understand width here. I understand the width of the wings. That makes sense to me. Who was it that suggested width? Was that Tatum? I think it was, and I think she's gone because she had to go do something else. Do any of you guys want to go with this width variable here, or should we maybe just drop that? Because when we talk about the wings, I mean, that width of the wings makes sense. So tell you what, let's get rid of that. Okay, so our next variable here now is fins. All right, so what do you think is reasonable to use as the low value for our fins variable? What would you recommend makes sense? Okay, so 0. So basically no fins. All right. Okay, so what does that mean? That means that when we take our piece of paper, the template or whatever, we don't cut any fins. Okay, so we're not going to cut any slots here. We're just going to roll it up. So we're going to have a tube with no fins whatsoever. All right, so that's a reasonable low value. I mean, in fact, kind of hard to go lower than that. Okay, so no fins, that's going to be our low value. For the medium value, how about if we go with the template design? When I say template size, what I mean by that is, I say that before we roll before we roll the sheet, we cut the slits exactly to the size as shown in the template. That would be our medium size fins. Okay. Now, what would we do for our large size fins then? Well, how about if we say twice the template size? Okay. So if we make fins that are twice as big as they're drawn on the template, then that would be the high value for our fins variable. So far, so good. Okay, hang on a sec while I sneeze. Okay, now let's talk wings now. Okay, so wings. All right, so the low value for there, well, that's obvious. Let's just say no wings. What about medium and high? This one's going to be a little bit tricky. What should we put down here for medium-sized wings and big wings? Now, I've seen a lot of students make paper airplanes, and I've seen that there are dozens and dozens of different ways that people like to make paper airplanes. So maybe what we can do is let's take that variable that we got rid of a few minutes ago, the one that says width, and let's have that be the size of the wings. Okay, so I have this paper airplane design, which is what I like. So if I measure that, my wings are about 8 inches. Would anybody want to go with wings that are bigger than 8 inches? That it seems to me that that would probably be the maximum size that anybody would realistically want to go with. Okay, so let's put that in as our maximum size for wings. So wings maximum here would be 8 inches wide. And so the medium then would be wings that are, let's say, 4 inches wide. That sound reasonable to you guys? Okay. What's our next variable? The nose. Okay. All right. So what would you recommend that we go with for our nose shape here? Well, how about for the low one, let's just say flat. And when I say flat, what I mean is that, let's see, where's all my rockets? I had a bunch of rockets. Okay. So what I mean by that is, remember how when we made the rocket, what we did was we just folded this in and it's basically flat right now. So that would be the low range for the nose, is we just make it be totally flat. Okay. And then, so then for our upper range is we would say really sharp. So a sharp point. And then for the medium range, we would just say maybe a roundish. Okay. I'm not sure if I like that term, but basically, halfway between being totally flat and being totally sharp. Okay. All right. So now basically, and by the way, what we're doing here, this is called the testing matrix. So let me come down here. So this is called the testing matrix. And let me make that be centered there. Okay, so what we're creating right now is called the testing matrix. It's a list of all of the different variables and all of the different settings that we might possibly want to test. So our testing matrix is almost finished now, but not quite. We've got one more variable here we want to play with, and that's how tight. Okay. Now this one is going to be really hard to go with. So in this case, let me just say loose. And over here, let me say tight. And here, I'm just going to have to say medium. And I realize that that's not a very good descriptive way to do it, but I can't think of a way to put a number on it. So kind of out of luck there. Okay, so we've got 1, 2, 3, 4, 5. We got 6 variables. Now that you guys have had a little time to think about it, can anybody think of any other variables that you might possibly want to play with? Can anybody think of anything else that we might want to do to a flyer that might possibly help it to fly better? The number of fins, okay. Okay. Tell you what I think I'm going to do with that. Let's just combine that in here with fins. So we got no fins, we got template fins, twice the template size. Let's just stick with 3 fins. Because if we go with the number of fins, that's just going to add an extra layer of complication. So I'm thinking we're done. Okay. So we have just created our testing matrix. And so that means we don't need to have any of these guys anymore because we've already captured them. Okay. So now these are the variables that might possibly affect the flight distance. Okay. And so this is something that I wanted you guys to do. Now, next thing is I want you to, so if we were to go with all of these things, if we were to make prototype rockets that test every possible combination of every possible variable, how many prototype rockets would we have to make? Okay. And by the way, I know that you guys are taking careful notes about everything we do, wink, wink, nudge, nudge. What we are starting to do right now is something extremely important. This is called the design of experiment process. Okay, so let me go up to the top here. So design of experiment. Okay. Let's make that be centered and maybe even make it be bold and underlined. Okay, so what we are doing is we are designing the experiment. And I guess it would help if I spelled the experiment right, huh? Okay, so we are trying to figure out how many prototype rockets would we have to make, how many prototype flyers would we have to make if we tested every single variable together with every other possible variable at every different level. How many different prototypes would we have to make? Okay. All right, let's see what you guys say. All right, so I see one person is saying that we would have to make 18 prototypes if we were to do this. Another person is saying we would have to make hundreds of prototypes if we were to do this. Okay, well, tell you what, let's go through the math. Let's approach this the way that your math teacher would like. Let's say let's go to a whiteboard. And so let's say that we got variable number 1. Let me turn on my annotation here. So variable number 1. And we've got 3 different settings for that. We've got low, medium, and high. Okay. So if there was one and only one variable that we had to play with, and if we were going to test that variable at 3 different levels, do you guys agree we'd have to make 3 prototypes, right? We make one. So let's say, what was our variable number 1? Let's say, well, whatever it was. Okay, length, or I don't care. Let's say that length was number 1. Okay. All right. So then if that was the only variable that we had to play with, then we would have to make three prototypes rockets. Would make a short rocket, would make a medium-sized rocket, and would make a long rocket. Okay. But that's not the only variable we need to play with. So what we need to do then is we need to look at what about variable number 2? All right. So whatever that is, maybe it's the number of pennies, or maybe it's the size of the wings. I don't care. I'm just going to call it variable number 2. Well, now variable number 2 also has 3 levels. So if we were to test all combinations, that means we would have to have a prototype rocket that was short, and we'd have to combine that with a prototype rocket that had all 3 of the possible variables for variable number 2. So tell you what, let's call this pennies, just so it's easier to understand. Okay, so we'd have to have a short rocket with no pennies. We'd have to have a short rocket with 2 pennies. We'd have to have a short rocket with 4 pennies. But we'd also have to have a medium rocket with 0 pennies. And would have to have a medium rocket with 2 pennies, and would have to have a medium rocket with 4 pennies. And then same thing with the long rocket. Would have to have a long rocket with 0, long rocket with 2, long rocket with 4. So how many rockets would we have to make? We would have to make 9 rockets. Okay. So make note of this when in your notebooks, which I know you guys are always taking really good notes, right? I want you to make note in your book that if we have 2 variables and 3 levels for each variable, then the number of prototypes equals 9. Now, get out your math skills here and ask me, how could I combine the numbers 2, 3? How could I combine the numbers 2 and 3 in order to get 9? Is 2 plus 3 equal to 9? Is 2 times 3 equal to 9? Or what could I do with 2 and 3 in order to get 9? What mathematical operation could I do? Nobody wants to suggest anything? Okay, 3 squared. Very good, Jared. Good for you. So if I say 3 raised to the 2nd power, okay, that would be 9. So this is the formula that we're going to use. So what we're going to do is we're going to take the number of levels and we're going to raise that to the power, where the power that we raise it to is the number of variables. Okay, and that is the formula that will tell us how many prototypes we need. Okay, the number of levels raised to the power of the number of variables. Okay, so now let's go back to our testing matrix here. So we have, let me turn on my annotation here. Come on, let me turn it on. So we have 3 levels how many variables do we have? We have 1, 2, 3, 4, 5, 6. So I want you guys to do the math and tell me if we were to test every single combination of variables, how many prototype flyers would we have to make? So we've got 6 variables. We got 3 levels for each variable. So I want you guys to get out your calculators. You should always have a calculator when you come to this class. If you don't have a calculator, pull out your phone, use your phone. So if we've got 3 levels and there are 6 variables, if we want to test every possible combination, how many prototype rockets would we have to make? Okay, so I'm starting to see a couple answers. Let's see what you guys get. Okay. All right, now what I see, I'm seeing 2 answers here. I'm seeing, some of you are saying that the answer is 729. Others of you are saying that the answer is 216. Okay, so why are we getting different answers? Let's go look at our whiteboard here. So we decided that the formula that we want to use is this formula right here. We're going to take the number of levels raised to the power where the power is the number of variables. Okay, so if we've got 6 variables and we got 3 levels, okay, so we could either do 3 raised to the 6th power, or we could do 6 raised to the 3rd power. And so if you look back here, you see the base is the number of levels. Okay, so we do not want to do 6 to the 3rd power. We want to do 3 to the 6th power. So 3 to the 6th power is 729. All right, so let me go back and start sharing this again. Okay, so if this is our test matrix here, hang on, boy, every time I make a change here, I have to turn annotation off and I have to turn it back on again and my screen doesn't like it. So if we've got 6 levels and we got 3 variables, then the number of prototypes is going to be 3 to the 6th power, then not 36. 3 raised to the 6th power. So that's 729 prototypes. Okay. So if we want to find out what design of the flyer is the best flyer, we would have to make 729 prototypes. Do you guys want to make 729 prototypes? I'm thinking you probably don't. Okay, so we need some way to make this more manageable. What to do? Anybody have any suggestions on how we can do a test here? So I'm going to make you do a bunch of prototypes. I'm not going to let you get away with just 1 or 2 prototypes. You're going to have to do several prototypes. But even though I'm mean, I am not so mean that I'm going to make you do 729. Even I'm not that mean. What could we do to test our flyers and find the best flyer design without making 729 prototypes? Anybody got any ideas? It's awful quiet out there. Nobody has ideas? Come on, somebody speak up. Somebody's got to have some ideas. Obviously, we're going to have to make some sacrifices somewhere.
Maybe you can reduce the amount of variables that we have.
Excellent. Yes, and how could we do that? Well, Paige just typed something in here. Paige said, base it off of your best judgment. And I like that idea. So both of you, you're both on the right track here. So what we're going to have to do is we're going to have to look at these variables here. And we're going to have to just use our intuition, you know, use our experience. Which ones do we think are probably going to have the biggest effect? Now, everybody has different experience. And so what I'm supposing is that everybody's going to come up with different variables. So here's what I want you guys to do. And I'm going to stop talking pretty soon, and I'm going to let you guys start working on your own pretty soon. But what I want you to do is I want you to use your intuition to determine the top three variables that you think are most likely to have the greatest effect. And we're going to call these the primary variables. Except we're going to spell it correctly. We're going to spell it like that. Okay, so this is part of what I want you guys to do on your own after I end this Zoom session, is I want you to pick the three variables that your best judgment, your intuition tells you that you think are probably going to have the most effect. And don't be surprised if the three variables that you pick are different than the three variables that somebody else picks. That's okay. All right. So you're going to pick your three variables. All right. So now let me open up another whiteboard. So if we narrow this down to only three variables, hang on a sec, my touch screen here, I wish was a little bit more sensitive. Okay, so if we list three variables, and if we keep with three levels for each variable, then I want you guys to tell me in the chat box, how many prototypes would you have to make now? Okay, so type it in the chat box in a private message. I don't want anybody else to see it. If we have three variables and we're testing three levels, how many prototypes would we have to make? All right, so I'm seeing some of you are saying 9. Some are saying 27. One of you is saying 6. So let's see. Alex, you were one of the ones that said 27. Why did you say 27?
Well, because 3 raised to the third power is 27.
Very good. 3 raised to the third power. Okay. So that is 3 times 3 times 3. So that's 27. Okay. So we've narrowed things down. I mean, it's much better. I mean, it used to be 700 and what? 700. It used to be 729 prototypes, and we decided that's too much. So by narrowing it down to only 3 variables, okay, that means now we've got 27 prototypes. That's a whole lot better, but that's still too many prototypes. I don't want you guys to have to make 27 prototypes. That's not good. So we're going to have to figure out another way to narrow things down again. So anybody got any suggestions? What can we do to narrow things down a little bit more? I don't want to cut down on the number of variables. 3 is the minimum number of variables I want to go with. So what's the other thing that I can play with to cut down the number of prototypes?
Level.
Yeah, cut down the number of levels. Duh, right? Okay, pretty clear. All right, so let's go back to our whiteboard here. So instead of doing 3 different levels, let's change it to say we only have to do 2 levels. Okay, so what's it going to be now? Everybody please type it in the chat box. Okay, so if we have picked our 3 primary variables and we've decided that we're only going to go with 2 levels rather than 3, right? So then now how many prototype rockets would we have to make? So I'm seeing some people are saying 9. Everybody, looks like everybody's saying 9. I'm a little bit worried. Remember the formula? The formula is the number of levels raised to the number of variables. Okay, so it's 2 levels raised to the number of variables. 2 to the 3rd power is not 9, guys. Okay, yeah, that's better. 2 to the 3rd power is 8. Okay, so this is a reasonable number of variables, or I'm sorry, a reasonable number of prototypes. Okay, this is okay. I think that I could ask you to do that, and I could sleep at night. All right, so here is the thing that I want you to do for your homework tonight. I want you to, first off, I want you to make up the test matrix, basically like this. So basically just copy this. So I want you to say up here, I want you to say, if we go with 6 variables and 3 levels, then this is our testing matrix. And the number of prototype flyers we'd need to make will be 729. Okay. And then I want you to come down here and say, well, that's way too many. So now here I don't want to actually type it for you. But so basically what I want you to do is I want you to say, okay, that's way too many. So what did we do? We decided to cut down the number of variables. And we're going to use our best intuition, our best judgment, to pick the 3 variables that we think are the most impactful. And we're also going to cut down the number of levels. Instead of doing 3 levels, we're going to do 2 levels. And so what I want you to do then is I want you to make up a new testing matrix. And I want you to do it on the same sheet of paper. So we're going to come down here, we're going to make up a new testing matrix. So our reduced actual testing matrix will be this. Okay, so and then I want you to come down here and I want you to add in a new table. Sorry, I've got other things in my in here. Okay, so we're going to have 3 variables. So you might think that we want 3 rows, but actually I want to have a header row. And we're going to have 2 levels. So we're going to add in a new table. It's going to be a 3x4 table. Okay, and so here we're going to have variable. And then here we're going to have low, and here we're going to have high. Okay, and so then I want you guys to fill this in. I want you to pick which of the 3 variables from the ones up above here, which of the 3 variables do you think? And then I want you to tell me what is the low and high setting for each one of those. Okay, and then I want you to write this all up in a report, or just a 1-page summary. You don't have to write a written report. Just send me a piece of paper showing me the 2 testing matrices, showing me the big testing matrix, and then showing me your reduced testing matrix. Okay, and then down at the bottom, I want you to just say, using this reduced testing matrix, we only need to make 8 prototype flyers instead of 729. Okay. Is that clear? So you don't need to make any prototypes yet. All you need to do is write this up. But if any of you are bored in between now and the next time we meet, and if in order to relieve your boredom, you want to try starting making some, you have my blessing. You're not required to do it, but I mean, you're going to have to do it eventually. So, you know, hey, you might as well do it sooner rather than later. But it's up to you. So your homework tonight is just write up the testing matrix. I want 2 testing matrix. One is the big matrix where we would have to do 729 prototypes, which is obviously too many. And then the other one is the reduced testing matrix where we have to do 8 prototypes. Okay, any questions about any of that? All right then. So you can go ahead and type bye into the chat box and make sure you turn in the homework before we meet next time. And then I will see you later. Now, just in case any of you had questions, but you didn't want to ask because you knew it was being recorded, here, I'll go ahead and stop the recording.